So today we're going to discuss one of the best strategies that we have ever created in our course or in our YouTube channel, and that's a combination of MACD with the machine learning or AI model called decision tree. And we're going to go deeper into what the uniqueness of this specific strategy is, and it's got some great performance results, which we've taken the commissions into account. And one of the reasons why I love these kind of strategies specifically is because it's on a portfolio of stocks. So the strategy is like spread out the portfolio. So we're not like putting all our money into one stock or one index ETF. It's like diversified across the stock. So we're going to discuss everything thoroughly, from the codes, the weaknesses, the strengths of these kind of strategies, and then you'll get a better understanding. So to start off with decision tree, this is not the first time we have discussed about decision tree. If you are not thorough in that, I would highly recommend that you watch the decision tree video here in our YouTube channel, and we have discussed it thoroughly. Everything from the input features to how a decision is made in an AI model, so you guys can get an understanding. And then what we're going to use is just basic MACD histogram, so I don't have to go deep into that one as well. Everybody knows MACD histogram is just basically the difference between the fast MA and the slow MA, and basically we've got a histogram, and based on that we are entering and exiting our position. So the thing we're going to use different here as compared to many of the machine learning models is the difference between the fixed window training and also the sliding window training. So for people who don't know the difference, a fixed window training is pretty much like, let's say we have created a model from 2000 to 2010 and we're training the model in that period. Then we are testing it from, let's say, 2010 to 2025. It's just an example. But even then, for that training and testing, we need to be intelligent, because the training has to have events which are kind of like a tail risk events, like a black swan event. So for example, between 2000 to 2010, we had black swan events in the dot-com bubble in 2001 and also the 2008 financial crisis as well. So when we test, as in out of sample data, that also should have some kind of a black swan event. So we know that the strategy survives if in case a black swan event has taken place. So for example, in the period of 2010 to 2025, we've had multiple situations. We had I think in 2022, 2023, we had the Russia-Ukraine and the high inflation rate scenario. We also had the interest rate hike scenario, and we also had the 2020 crash. We also had the high tariff scenario that's going on currently right now. And when the strategy performs well, it's not something special. Like for instance, this is one of our strategies which has been in inception since our course starting in 2001, and it's not a machine learning or AI model, but it's still a quantitative trading strategy which went through a training and testing data. And the reason why this strategy has performed well is not because I'm special or the strategy is special or anything on that, but it's been trained in black swan events like the 2001 dot-com bubble and 2008 financial crisis, and that's why even when the market went down during the 2022-23, it performed well, and even currently now it's performing some good trades right now. So if I can go into some of the trade signals it generated right now, it's like short here, short here, short there, and again short signal. Now it's not that all the trades will work. There'll be trades that go wrong against you as well, but on average during high volatile moments it will tend to make money because it's a mean reverting strategy. So because we have trained it in black swan events, that's why it survives, and not only survives, it succeeds during a black swan event. It's just like if you have trained in push-up and pull-ups, if during the competition they do actually give you push-ups and pull-ups, you can succeed in it. And that's how simple training and testing is. So this is a very good example of a fixed window training. But in this model, in this strategy, the MACD plus decision tree model, we are using a sliding window training. So sliding window is basically the training sets keeps on moving, it keeps on changing. It's not a constant. It keeps on adapting to newer market environment, and then we test on a future date. So it'll be like training for X amount of date and then testing, and then the training goes to the most recent one. It completely forgets about the old training results and old training data, and a new fresh training data is generated, and the out of sample data, the testing sample, is moved forward. So you've got multiple training and testing data. So there's lots of advantages in using a sliding window training as compared to a fixed window, but it also comes with a drawback as well. So I'm just going to give you a rough example of sliding window training testing. So let's assume that today is June 1st. So what it's going to do is it's going to take the previous 60 days to train, and then it's going to test till July 1st for like 30 days. Okay, and then when July 1st reaches, it goes to the most recent 60 days. That might be from May, entirety of May to entirety of June, and then uses that model to trade from July to August. And when August reaches, the same thing, it trains on the most recent 60 days and then tests on the 30 days. So in this strategy, we're not doing 60-30, we're doing 100 days of training and 30 days of testing. But the reason why I put a 60-30 days is just for like an example so you guys can understand how it kind of works. So here's again a tabular format, like basically if on June 1st, the testing will be from June 1st to June 30. So June 1st to June 30, when we trade, it'll be based on the training for the entirety of April 1st to May 31st. So this is May 30, 31st. I'm just taking a round figure because 60 days can be, exactly 60 days. So these dates might not be exactly correct, but you can say the entirety of April and entirety of May is the training data for the June 1 test, which lasts till June 30. And for the July 1 test till July 30th test, it's the entirety of May and entirety of June. And when we reach August 1st, then August 1st to September 1st, when we trade, the entire training data for the model is between June 1st and July 31st. And that'll keep on rolling over every single time. So the sliding window is also called rolling over period training model as well. So let's go into the comparison between the fixed window and the sliding window. So fixed window, just as we discussed before, its training is fixed, so there is no retraining unless and until we manually do it. So in the code, it will be fixed and there is no specific retraining. So on the sliding window, the training is always going forward. It's retrained on the most recent data, and as I said before, we're forgetting what we trained prior. Now testing as well, it is fixed, just as I said, between 2010 and 2025. Now in the sliding window, the testing follows each training. Also, the adaptability on fixed window is low because we have actually made the training data to be fixed. We're not changing anything, right? So there is no adaptability to recent market conditions. On the other hand, in the sliding window, the adaptability is very high and it adopts to newer market environments and newer market conditions. So for example, right now, because of the high tariff scenario and the market volatility, the training model will pick that up and will adjust accordingly. But if in case there is a change in the volatility, then that can cost you as well. So it's like a double-edged sword, really, the sliding window. So what's the best use case scenario for a fixed window and a sliding window? So the fixed windows use case is it's basically for longer term trading. So for example, the 2010 model that we use, we can keep on running it for a long time, and then because we've got two black swan events during that time period. So there's an intelligence factor in that as well. You have to be really careful in choosing the training period, because if you choose like a rubbish training period with no black swan events in there, then your training data set is like useless to market condition, and that in the testing you will see as well. The testing, the results will be horrible, and that's kind of like a red flag that you will know, and that's essentially the reason why we're doing in sample and out of sample training and testing. So that's one of the advantages of the fixed window and disadvantage of sliding window. It's preferably it's a longer term trading, and then it learns a lot. On the other hand, the sliding window, the learning is kind of not too much learning, and also the advantage, it's good for black swan events, because just like that in sliding window it can forget, because since we're using like 60 days, or in this example on the actual strategy we're using 100 days, it doesn't remember, it doesn't have any kind of memory of the black swan events because it's not in that model. So the use case for sliding window is that it is any term trading, so it can be short term trading, it can be slightly longer term trading, but preferably to slightly shorter term window. It's got adaptive learning, and it's not black swan proof. It's sensitive to recent market events. So whatever happens recently, just like I said about the tariffs, it is sensitive to that, and it will give out good results for that. But it is blind to historical tail risks. So there is that, one of the disadvantages of the sliding window. So what's the advantage for us in the machine learning model with respect to our strategy of the sliding window? So one of the biggest advantage of AI or machine learning is basically everybody's strategy is unique. So even if you go get these codes for our core students and you apply it, you will bring out your own changes. You might bring out changes in the training period, in the testing period. You're going to bring out changes in the input features. You're going to bring in changes to the MACD values. So the problem with many of the strategies out there, which is discussed on YouTube or in public, is that there is this thing called alpha decay. So alpha decay is basically like everybody is doing the exact same strategy, and because everybody is doing the exact same strategy, the strategy loses its efficacy. So you tend to get lesser returns on that specific strategy. So when it comes to AI or ML model, the chance of me having the same model as you is quite highly unlikely, because there are lots of variations from, like I said, from the data, from the training data, the testing data, the training epochs, to the decision tree windows, to what the input features are. There is tons of changes that can be bought. So there is no worry about this alpha decay, or you could say the alpha decay is quite less. So me and you can use the exact same decision tree model, but just because we have a completely different indicator, completely different input features, we get a completely different result and completely different performance, and which is a good thing. So not many people can copy, or not many people creates an issue of that alpha decay. So your strategy seems to be quite unique, and because of the rolling over or the sliding window training model, it adapts to the current market conditions as well. So it adapts to the choppy and the stable market conditions. So if it's choppy now, it adapts to choppy, and if the entire year is choppy, then your sliding window has done a pretty decent well. But on the other hand, if it's trending again, it can actually do well during that market conditions as well. So the other advantage of sliding window is that it's got multiple training and testing sets. It's not just one training and one testing as compared to the fixed window. So it's not at all overfit as compared to fixed window. So in the fixed window, remember I told you have to be intelligent in the training period. So we have to make sure that there's black swan events in the training period. But in the if somebody chooses a training period, which is everything is like trending markets, so suddenly you've got an overfit phenomenon. And then during the testing stage as well, if it's all trending, now suddenly you've got a training scenario, training period which is all trending, and testing period which is all trending, and now you've got like an overfit trading strategy, and you think that the strategy has worked well in the training and testing, but in reality it has not. It's just an overfit result. So it can't be trusted. And there's where intelligence and trading intelligence and math intelligence all come into into a complete package. Because as a trader, from your personal experience that there's going to be lots of black swan events, so you have to put that into the training data, and you have to make sure that in the testing data it's also there. So sliding window completely avoids this problem by only focusing on the recent one, and because of that they don't have to worry about any kind of overfit of the previous results or too much trending scenarios and all those things. But again, it comes back to the drawbacks as well because of the tail risk. Now adding this sliding window approach or rolling over approach is actually quite good, because you don't want all your strategies to be fixed window, because many of our strategies like the neural networks and all those strategies are kind of like fixed window. So having these kind of strategy which is rolling window kind of gives you a diversification of strategy portfolio, and that is very crucial in creating a very efficient quantitative portfolio of strategy. So let's go into the codes now. So I'll just go into the code. So the entire code is available to our core students in our quant program. So this will be a newer addition to our strategies for the machine learning and AI. So as of now, including this one, there will be a 9, because there's a decision tree strategy, second one we added a few weeks ago. So we have linear regression, decision tree, support vector machines, recurrent neural network, long short-term memory. We also have discussed combination of RNN and regression, combination of recurrent neural network and support vector machine, and then decision tree 2, and this one will be the third decision tree that we will be adding. And all these strategies has beaten the S&P 500 CAGR to drawdown ratio, and that is very crucial. And this number is what quants are targeting for, the CAGR to drawdown ratio. And I've also created an article here which explains detail on why Sharpe ratio is not a good performance measure and why you have to use CAGR to maximum drawdown ratio. You can even discuss that with your favorite LLM, but again, if you want to go through the blog article, that'll be good as well. So let's go through the codes of this strategy. So basically we are importing the decision tree classifier, which is a library that's available for Python and the scikit library. We can easily do that in Quant Connect, and we're also using the standard scaler. So our testing will be from 2010 to 2024, and we are doing a capital allocation of 5%. So there will be a maximum of 20 positions, and each position will have 5% allocated to it. And then we've added things like we had the SPY, we have actually added the rebalance time, the model train time. We have brought in the decision tree classifier. We have chosen the max depth of 5. This is also one of the values that you could change. You can have a higher max depth, and that also is discussed in the course, the things that we can change to make the machine learning model superior, but also making sure that it doesn't have any overfitting issues. We've given a complete PDF on the values that you could change, and then obviously the standard scalar values to make sure that the values that we pull in are good. And then we have chosen the stocks based on the fundamental data. So we check if the stock has got fundamental data, and we have also filtered it using dollar volume. So we are only trading the stocks which has got liquidity. So we are kind of filtering it based on the highest amount of liquidity. So by checking at the dollar volume, we can know that, hey, those 100 stocks that we have selected in that portfolio comes from highly liquid ones. So we don't want to trade illiquid markets because that'll mean more slippages and issues like that. And we are going to rebalance every 30 days. So remember the 30 days, that every 30 days we are going to have a newer training. And that's what we have fed in here. And this is just the on security changes, adding in the stocks and removing the stocks. And then here is the model to train, 30 days. And then we have added in some of the other factors that we will be putting in, like the SPY, simple moving average. So we want to check that as well. And then we're going to check in the capital allocation, so that we are making sure that it's only 5% invested in it. And here is where we will get the features of our machine learning model, and we're going to do the scalar transform, and we're going to predict it, right? And then we are going to make sure whether we are going to enter or not. So we're going to make sure the MACD histogram is greater than 0, and we're going to make sure the prediction is equal to 1, and it's only then we will enter into a trade. So and once that's done, we will enter into trade. And here is the training the model. We are training the model. First we're getting the features, and then we are fitting the model. So the features part, I'm going to hide it a bit because I don't want to give away lots of information, just like I said about the alpha decay. But this entire code is available for our core students. But again, I would recommend you don't use the entire features that I do. Maybe you might have better ideas to put in the features much better than mine. So here I think we put in like 5 input features. You could minimize it to 3. You could come up with your own original ideas for input features, and that input features is what makes the model effective. And once we get the model in here, and then the prediction makes the signal, and then we enter. Same thing goes for MACD histogram. I have chosen a specific MACD histogram values, which again I think I have done a video on MACD histogram long time ago here. So those are the values that I have kind of got inspiration from in creating the MACD for myself. And that's it. That's basically the strategy in a nutshell. And let's see the results for this one. So this is the results, and we have taken commission into account. Most people who are discussing strategies in YouTube generally do not take commissions into account. We have taken commissions based on the Interactive Brokers platform, and you can see a plethora of stocks here that has traded over this period of time. And you can see all these stocks to a certain extent has got, it's famous stocks, and that the reason why it's famous is because it's got higher liquidity and higher volume, because that's the filtration that we have done. We've got McDonald's, we've got Tesla, Adobe, Nike, and all these things. And let's see the results of all these things. So the results is the compounding annual return of 18%, 18.843, and a drawdown of 33%. So that is a CAGR to drawdown, 18.8 divided by, what's that? 33.2, which is 0.56, which is extremely good, which is one of the best we've got in our course. So let's see, during that same time period, right? The same time period, let's see what is the performance on the S&P 500. So this is between 2010 to 2024. So I'm just going to go to ChatGPT. So between 2010 and 2025, what was the maximum drawdown SPX? The maximum drawdown was 34%, and that is one of the red flags of this strategy. So in this strategy, our drawdown is also not that good. The drawdown is 33%. So from that perspective, this is not good. So this could be one of the drawbacks of the sliding window. And if you can see, the drawdown came back in 2020 during the COVID crash. And if you can see in the during that period, that's also the exact same time where the the crash happened in the COVID as well. So it was not really good from a perspective of pure drawdown. But when it comes to return, the CAGR, the S&P 500 was 8.83%, but our strategy had like 18% CAGR. So that is huge. So that is spectacular, to be honest. So if you are comparing it from a CAGR to drawdown ratio, the S&P 500 between 2010 to 2025 is approximately 0.26, but on the other hand, our strategy was 0.56. So from the perspective of a pure return to drawdown ratio, we have succeeded. From a perspective of pure CAGR ratio, we have succeeded tremendously at 18.84%. But just because this sliding window is showing a drawdown of 33%, like I said, it's because of not factoring in for that tail risk. That's one of the drawbacks. But MACD also could have bought in the factors. The MACD value could have bought in the factors. So for example, this is one of the strategies, which is our decision tree portfolio strategy, which we did. We used a Bollinger Band for this instead of the MACD. And for example, this one, our CAGR is reduced to 10%, but you can see the drawdown is just 23%. So it depends on the many factors. It's just not one factor. And the biggest drawdown came in here on 2023. So you can see the changes depending on different input features. For example, in this Bollinger Band strategy that we did for our portfolio stocks, what we did specifically, I can give you one clue. One of the input features that we did was the position of where the market is before breaking the top of the Bollinger Band high. So those are some of the cool things that you can bring into the input features. In fact, one of the other input features, I can give you a clue, again, not a clue, a tip really, for this specific strategy. We provided 18%. One of the input features that I use was volume ratio. So I'll take the volume of the previous 30 days and compare to the volume of 60 days and see what the ratio is, and I can feed it to the input feature and they'll find out if that volume has got a specific edge. So normally when the market goes up, and if it's a high volume, you've heard that, that's like a good thing. So maybe the machine learning model pick that up on it. So there are lots of input features, cool input features that you can add it to your machine learning models, and you can add it to the code because code is already created. So you just have to change the values of the machine learning models and the input features, and you could run this whole strategy for yourself. So hopefully you enjoyed this video. You understood how to apply fixed window and also a sliding window, the difference between them both. And if you want to go detail about the decision tree model, obviously it's here. And if you don't know anything about algorithmic trading, and if you're not good in coding as such in general, then I would really suggest you do the algorithmic trading full tutorial. That should keep you understand this code in Python much efficiently. You can also go through the Quant Connect tutorial video as well. That is also pretty good here, this one, to understand how the strategies are coded. Let me know if you have any questions in the comment, or send an email. I'll be more than happy to help if I see if it's something that I can contribute to the community. Hope you enjoyed this video. Have an amazing day. Bye-bye.